Starting with the next question. We are given that fx plus y, x, y. So repeating this again and again, so we'll get f n minus 1 x plus x equals to. So opening this again, we'll get this is fn minus 2 x plus 2 fx and so on. So finally we can say we have fn x and setting x and y is 0, we get f0 equals to 2f0, which means f0 is 0. We have this result where n is a natural, obviously. And replacing x by x by n, we get fn x by n to n f x by n, which gives us f of x by n. So combining this with this, we get m by n equals to m by n times fx. Similar argument, similar steps will yield the result that g m by n x is equals to gx to the power m by n. We are also given gx plus y equals to gx gy. Substituting x and y as 0, we get g0, so g square 0. Which means g0 is either 0 or 1, but it cannot be 0 because then we'll have gx plus 0, which will be identically 0 if g0 is 0, but that's not true because g minus 1 by 3 is given to be non-zero. So we have g0 is equals to 1. Then f of 1 by 4 is equals to f of 5 by 12 minus 5 by 12 into minus 3 by 5, which is, using this rule, minus 5 by 12 times f of minus 3 by 5, which is f of minus 3 by 5 is equals to minus 5 by 12 times 12. G of minus 2 is g 6 times minus 1 by 3, which using this rule we have g minus 1 by 3 to the power 6, 2 to the power 6. So we have all the values required. Let's substitute. We have f1 by 4 is minus 5 plus g of minus 2 is 64 minus 8 times g0 is 1. This is 51.